Alright, thanks for tuning in to another physics lesson with Mr. M. Today's lesson will be on energy and its conservation. This is a quite important topic for us, especially in today's day where we're trying to solve for better ways to utilize our energy, to have clean energy. So we're going to talk a little bit about energy's forms, the forms that it comes in, and we're going to talk a little bit about how energy is conserved. Okay, so let's go ahead and take a look at it. So the first thing is we kind of need to know what energy is, and you might be thinking, hey, I know what energy is, but if you tried to put it in words, it might be a little bit difficult. So our physics definition of energy is the capacity or ability to do work. So what that just means is for us to be able to do anything, we need to have energy. And as we may know, that energy takes many forms. One of the main forms that we're going to be taking a look at in this lesson is mechanical energy, which is an object's kinetic and potential energy put together. But we know that other forms include electricity, chemical energy, heat or thermal energy, nuclear energy, the list goes on and on. We have many forms, and what you also might already know is that energy can transform from one form to another. An example of this would be like a hair dryer. It takes the electrical energy that you have it plugged into the outlet and it turns it into heat so that you can dry your hair. Another example would be like a car engine, which takes the chemical energy of the gasoline, the chemical bonds, and it breaks those chemical bonds so that it can get some movement, which is also known as kinetic energy. And we know that when we burn anything or combust anything, that we also get heat, so we also get some thermal energy out of that. Another example would be like a skydiver who turns his potential energy, the fact that he's really high up in the air, and when he jumps off that plane, he converts all of that stored energy in its height and turns it into movement, which once again is known as kinetic energy. Okay? The cool thing here is that when energy gets transformed, it's also conserved. And if you don't recall, to conserve something just means to prevent the loss of. So as we go from one form of energy to another form of energy, that energy is not lost. It's just changed. Okay? So our formal definition here of conservation of energy is just that our total energy before transformation is equal to the total energy after transformation. And so in other words, the total amount of energy does not change. We are not adding or losing any energy. As long as, so we have one condition here, as long as the system is closed and isolated, which just means that we're not changing the mass of our object or objects, and we're not including any external forces. Okay? Now, one of the applications that we tend to talk about in physics with the conservation of energy is the conservation of mechanical energy. So I just want to talk a little bit about mechanical energy, and then we'll finish up. So our mechanical energy, and we're talking specifically about one object here, is that one object's kinetic energy plus its potential energy. So both of these together add up to our total mechanical energy. And so our kinetic energy, which gets the abbreviation KE, is just our movement energy or motion. If we have movement, we have kinetic energy. And the equation that we have for our kinetic energy is that in terms of that one object, it's going to be 1/2 that object's mass times its velocity squared. Okay, so simple equation here. Now, that's potential energy, or we're going to specifically be talking about its gravitational potential energy, gets the abbreviation PE, or sometimes capital U. I tend to use PE. And that's just the energy due to the object's height. So you may have already encountered this, but the higher you go up, the more energy you're going to have. So like a roller coaster, if you have a really high a really tall roller coaster, you're going to go a lot faster once you go down the hill. But if the roller coaster is, a small hill, you're not going to go as fast. All right, and so the equation that we have for potential energy is that object's mass times gravity times height. And so once again, the higher we are, the more potential energy that we have. Now, whenever we solve for energy, it has a particular unit, and that unit is called joules. It's named after one of the scientists whose last name was Joules, who worked a lot with energy, and so the abbreviation for our unit is going to be a capital J. Now I just want to show you quickly how we can actually kind of put this into an equation. In terms of our conservation of mechanical energy, looks a little bit similar to the equation for the conservation of momentum, in the fact that our total initial mechanical energy, our total energy initially, has to equal our total final energy as well. And so we always add KE and PE together, our kinetic energy and potential energy. We always add them together to get our mechanical energy. So whatever we have to begin with is what we should finish with. And I'm just going to show you in this picture how that kind of works. Now in the picture we have looks like a snowboarder going down a hill, and at the very top the snowboarder is not moving. And so if we are not moving, we have zero kinetic energy. All of our energy then is due to our height in terms of our potential energy. Okay? But you can see if we add our KE and our PE here, we get 50,000 joules. Well, at every single other point that you see on this picture, our kinetic energy and our potential energy add up to 50,000. Okay? So at the top we had no kinetic energy and all of our energy was potential, but when we got to the very bottom, if you take a look down here, where our height would now be 0, our potential energy is now 0, and our kinetic energy, or all of our energy now has transformed into movement, is now 50,000. Okay? But one of the main things is that if you look at every single point in the snowboarder's position, and its total energy will always add up to what we started with. Okay, so this is a very important concept when doing a math problem, to kind of have it's all based on this concept that whatever energy that you started with, you're going to end with the same amount of energy. Okay, so hopefully this lesson was helpful for you in solving for a conservation of energy type problem, or if you have trouble with the different transformations of energy. I hope this video and lesson was helpful for you. Thanks for tuning in.